Hello everyone, you are watching Learn Easy with us. We provide educational and training videos every day. To stay updated with our latest content, please click the subscribe button and hit the bell icon so you never miss a video. Please share your valuable feedback in the comments below after watching the video. Without any delay, let's get started. Ready? Let's dive into today's topic.
All right, guys, it's time for the final project of today. And the goal is to be able to write some code here in Reborg's world to be able to get our little robot to be able to navigate to the goal and go through a maze no matter what the maze looks like. So if you go back to Reborg's world, if you already got a link open, if you don't, then simply click on the direct link in the course resources and it should take you here. And we've got the maze selected in the drop down, which is right here. Here we have a maze, and even though the maze doesn't change, the robot does. The direction that the robot is going to face is completely random. The position of the robot is also random, so you can see every time I restart the game, it will face a different direction. So in this case, it's facing up, but the next time it might be facing down in this case. And it's also always going to start at a random location in the maze. If you click on the world info, it'll tell you that the secret to getting the robot to complete the maze is to get it to follow along the right edge of the maze. If it starts anywhere in the maze and it just continue following along the right wall, it should eventually get to the final destination. For example, like this. Now, in this case, the robot is not making a beeline straight to the exit as if it could see what we can see, but it is following a strategy, or rather what you would call in programming an algorithm. And the algorithm here is to simply follow along the right edge of the wall, and if the right side is clear, then continue going right until it's no longer clear, at which point it should just go straight. And if you can't go straight and you can't go right, then the last option is to turn left. It's almost like the robot is getting a set of instructions in terms of hierarchy. The most important, telling it to turn right if it can. If it can't turn right, then go straight ahead. And finally, if it can't turn right or go straight ahead, then to turn left as a last resort. So you're going to need to use a lot of the functions that you saw previously, such as move, turn left, and testing whether if the front is clear or the right is clear, or there's a wall in the front or a wall in the right, and whether if the robot is at the goal. Think about how you can use a while loop and also the conditional if, elif, else statements to achieve this goal and get our robot to be able to go to the final destination no matter where it starts out and what direction it's facing. Pause the video now and try to use what you've learned to complete this final project. All right, so did you manage to complete this challenge? If not, let's work through the solution together. The first thing we need to do, which we've always pretty much needed completing each of these challenges, is we need a way to turn right. So I'm not going to type it all out again. This should be already pretty clear. Turn right is just turning left 3 times. Now, the next thing we need to do is we need to tell the robot to do things and to check for things until it reaches the goal. We know that we have this test called at goal, so we can use a while loop to get the robot to continue working until it reaches the goal. To define that, we could say while not at goal. So basically keep repeating the instructions inside this while loop until at goal becomes true and not true is false. So once this condition becomes false, then our while loop stops. So what we were told in the world info is we should follow along the right edge. We should test to see if the right side is clear. And if it is, then we should turn right and go straight. So that basically means moving right. Let's use an if statement to test if right is clear. And in this instance, so in this if block, we're going to say, well, turn right using our pre-built function up here. And then once you're facing the right, then move forwards. This should achieve a right move. So from here to here, for example. Now let's test this and see what happens. In this case, the right is clear, so it moved right. The right is not clear, so it doesn't know what else to do, and it's now stuck in what we would call an infinite loop. And it will never stop until the browser actually forces it to by crashing. So what we have to do instead is we have to provide an alternative condition. When the right is not clear, what should it do? So we're going to provide that condition by using an elif statement. And what we want to say is if the right is not clear, well, then maybe you should check if the front is clear. And if that is the case, then simply just move forwards. Now, this would work unless we're in the situation that we're in right now, where we're boxed in and the only side that's clear is actually the remaining one, which is the left. That's why we have to put in the last line of code, which is going to be an else statement. So in all other conditions, when the right is not clear and the front is not clear, so once both of these have been checked and they're false, then actually just turn left. So now you can see that when our robot is able to go right, it will try to follow along the right wall, but when it can't go right, it'll go forwards instead. And when it can't go right or go forwards, then it's going to turn left, and hopefully the next time it checks the loop, the front will be clear and it will be able to move forwards. So notice how our robot is somewhat haphazardly navigating through this maze, but it is following the algorithm that we specified, which is to follow along the right-handed wall until you reach the goal. And that's what these few lines of code does using our while statements, our if, elif, else statements, and also our turn right function. Now, while everything seems to work all right, there are select cases where the robot might start at a position and face a particular direction that gets the robot into an endless loop. So here's an example. Let's say the robot starts off at this particular position facing down. If we go ahead and let the robot run the code, you can see that firstly, there's over 1,000 steps in the code. And what happens is because the robot doesn't have a wall on its right, it's going to keep looping through this circle. Because after all, we're telling it, if your right side is clear, turn right and then move. And the right is always clear when it's inside this boundary box. So depending on where the robot starts out, it might get itself into what we call an infinite loop, because you can see the code just goes again and again through this while statement, and the robot's never going to be able to escape from this position. So this is one of the things that happens to your programs. Sometimes there are edge cases which you might not have thought of, but it's only through testing the code that you discover them. Now, this particular issue, I would say, is more of an intermediate debugging problem. So if you're somebody who's already really comfortable with Python and you want to try out debugging this particular problem, then I've included some problem worlds for you to test your code against. Now, if you are somebody who is still getting to grips with Python, I would say this is not the right time point to tackle this challenge, and I would go ahead and make a note to yourself that once you've completed day 15 and you're firmly within the intermediate territory of Python, to come back to this problem and to continue to debug this particular edge case. Now, if you are a beginner, I recommend to skip the rest of the video, but make a bookmark and make a note here so that you know to come back. Now, if you are more of an intermediate programmer, then let's go ahead and debug this. So what you can do with Reborg's World is you can actually create a file to load up a particular map and robot positions. And then in Reborg's World, you're going to click on Additional Options, Open World from File, and you're going to select that folder, which hopefully you've unzipped, and go through each of these problem worlds, testing your code in all of the cases. Now, when you open this up, you can close off this box and the robot will start at a particular problem position facing a direction that is going to cause it to go into an infinite loop. And you can know this ahead of time because when you actually go to start the robot and you hit play, when you can see the number of steps here over 1,000, it usually means that you're probably in a situation where it's going to turn into an infinite loop. So write your code here and then test it to make sure that the step count goes down below 1,000 and your robot doesn't get stuck in this endless circle. Now, because the different problem worlds can have different solutions, but what you're aiming for is one solution code that solves all of the problem worlds, I want you to test your code against all 3 of these problem worlds I've created for you. So here's the time, if you want to tackle this challenge, to go ahead and pause the video and see if you can debug this pretty hard problem. It took me a while, so I think it's going to take you a while as well, but you might be smarter, it might take less time. So good luck, pause the video, and we'll go through the solution together a little bit later on. All right, so first, let's try and figure out what the problem is. The problem here is that every time when the robot's right side is clear, our code tells it to turn to that direction, move forwards, and then check to see if it's at the goal. So it's not, and then again, the right side is clear, so it turns right and moves, turns right and moves, turns right and moves. So basically, in any of these 4 positions, depending on the way it's facing, there might not be a wall on the right side of the robot. So that is the key to solving this bug. We have to get our robot to a starting position where it has a wall on the right side of the robot. Now, I've been thinking about various ways of doing this, and the shortest, most succinct way that's also most understandable, I think, is this. So if we create another while loop before this while loop runs, so remember the code goes from top to bottom, it's going to hit this while loop first, and we check while the front is clear, well then the robot is not next to a wall, right? Such as in this case. Well, if that is the case, we're going to tell our robot to just move forwards. So this means that our robot is going to seek out a wall. So in this case, for example, it's going to go forwards until it reaches a wall. So it's going to loop through that loop twice, and it moves twice until it hits a wall in front. Now this is the point which we want, because we want to make sure that now that it's hit a wall in front, that it's definitely got a wall on the right side of the robot. So what do? Well, once it's hit a wall, so it's exited this while loop, we're going to tell it to turn left. So this loop makes sure that the robot has a wall in front of it, and once it's found a wall in front, we tell it to turn left to turn that wall onto the right side of the robot. So now you can see we're going through this while loop. First, front is clear, so it's going to move. And then front is still clear after that one move, so it's going to move again until it's hit a wall in front. Now at this point, it exits the while loop and it goes to the next line of instruction, which tells it to turn left. Now that the robot has turned left, it now has a wall on the right side, and it enters the next loop. So in this loop, if the right side is clear, turn right and move. If the front is clear, just simply move forwards. Otherwise, turn left. So as long as the robot starts at a position where there is a wall on the right side of it, right next to it, it's never going to get into that infinite loop with this code. So this is one solution to this problem. Now, there's lots of other solutions, but what you got to make sure is that your solution works in every single one of these test cases. So we can go ahead and open up problem world 2, where the robot starts at a different position, facing a different position, and we want to make sure that still we don't have an infinite loop. In this case, it doesn't, so that's great. And finally, let's test the last one, which is problem world 3. And now we can run our program, and you can see it's also less than 1,000 steps, so it works. So this is a bit of advanced debugging, because we're now testing our code against various terrible scenarios where the robot starts off at a position where it's really dangerous and can get into these infinite loops. Now, if you didn't manage to get the solution, don't despair and don't be too hard on yourself. This is a really hard one, and it took me a long time to find a solution that I think is readable and explainable and sort of makes sense. Now, it might be that you should put in a note in your calendar to come and revisit this issue in a week once you've had some time to think about it and to really digest and understand the solution. Then try to write the code yourself, because you will have forgotten exactly what the code was, but you'll still remember how it works. So if that is the case, this is what you should do. If you solved it by yourself, then congratulations. This is really, truly quite a difficult task.
Thanks for watching the video till the end. Please leave your thoughts below so we can discuss more about the topic. If you'd like to suggest a video that could help the community, feel free to message me on X or Instagram. We also share short videos on Instagram, so make sure to follow us there. Feel free to reach out. We'd love to hear from you, and might even create a video based on your suggestion.